Welcome. Today we are going to discuss some problems related to size of the test and power function of the test. And here the question is given a random sample of size 10 from uniform 0, theta distribution for testing h0 theta is less than or equal to 10 versus h1 theta is greater than 10 and the test function is given by phi of xn equal to 1 if xn is greater than k, 0 otherwise. So here we want to compute the size of the test when k equal to 9 and also obtain the power function of the test when theta equal to 8.5, 9, 10, 15, 20 and 25. Here what is xn? Xn is nth order statistic, right? You have studied in second semester in distribution theory, right? Xn, nth order statistic. So here we want to obtain the size of the test and also obtain power function of the test for the values theta 8.5, 9, 10, 15, 20 and 25, right? So in this problem is given that n equal to 10, right? So here see the sample size 10 from uniform 0, theta distribution, right? So here sample size n equal to 10 and what is theta naught here? And what is theta naught here? Theta naught is 10, right? Then what is k here? K is given, k is 9. So these are the given fact. Then we have to find out the size of the test, right? Size equal to supremum value of expectation of phi of x under theta belongs to theta naught. This is the definition for size, right? So in this problem, supremum expectation of phi of, here the test function is phi of xn, right? So here expectation of phi of xn under theta belongs to theta naught, right? So in this problem, what is h naught? Theta is less than or equal to 10, right? So which is less than or equal to 10. In this problem, the null hypothesis is less than or equal to 10. So we have to find out the supremum value of expectation of phi of xn under these theta is less than or equal to 10. So for that, first we have to find out the particular value which maximize this expectation of xn, right? So for that, first we have to find out whether this function is a increasing function or decreasing function, right? So for that, first you will take expectation of phi of xn as beta of theta. Beta of theta equal to expectation of phi of xn. Okay, so here consider beta of theta equal to expectation of phi of xn, right? Which is equal to 1 into probability of xn greater than k plus 0 into probability of xn is less than or equal to k, right? So here expectation of phi of xn equal to 1 into probability of xn greater than k plus 0, right? So here under theta is less than or equal to 10. Theta is less than or equal to 10. So here we can take as theta naught, okay? You know that theta naught equal to 10. Then which is equal to probability of xn which is greater than k, right? So what is the value of probability of xn greater than k? So for that, first we have to find out the density of nth order statistic, right? What is the function of density of nth order statistic? How to find out density of nth order statistic? There is one formula, right? That is f of xn equal to n into capital F of x, here x equal to xn, right? Power n minus 1 into f of x, where x equal to xn, right? So in this problem, x follows which distribution? Here given, right? Given a random sample of size 10 from uniform 0, theta distribution, right? So if x follows uniform 0, theta distribution, then what is f of x? Is 1 by theta, right? That is 0 less than equal to x less than equal to theta. Then what is f? Capital F of x is equal to integral over 0 to x f of x dx, right? Is equal to 0 to x 1 by theta dx is equal to 1 by theta into x by theta, right? Then what is the value here? It's equal to n into f of x. Here f of x is x by n, right? F of x is x by n, but here is given that x equal to xn, so x by theta, right? Here capital F of x equal to x by theta, capital F of x equal to x by theta, right? Here also given that x equal to xn, so you have to write these x as xn power n minus 1. And what is f of x here? F of x is 1 by theta, where x equal to xn. Here there is not have any x term, right? So this is the final term. That is density of nth order statistic is n into xn divided by theta and whole to power n minus 1 into 1 by theta. So we can write it as f of xn equal to n into xn power n minus 1 divided by theta power n minus 1 into 1 by theta, right? Which is same as n by theta, that is theta n minus 1 into theta, which is equal to theta power n, right? Then remaining term xn power n minus 1, xn power n minus 1. This is nth order statistic for x follows uniform 0, theta distribution. Then what is the range? 0 less than equal to xn less than equal to theta is the range. Understood? Then we are finding these beta of theta value, right? So then beta of theta equal to, here what is beta of theta? Here is probability of xn which is greater than k, theta is less than equal to theta naught. Here we got the nth order statistic for x is follow uniform 0, theta distribution, right? So then here probability of xn greater than k, theta less than equal to theta naught is which is equal to, here xn is range 0 to theta, right? but here we want to find out probability of xn is less than k. So the lower limit is become k, right? K to theta. K to theta f of xn d of f of xn dxn, right? Which is equal to k to theta. What is f of xn value? Is n divided by theta power n xn power n minus 1, right? So here n xn power n minus 1 divided by theta power n dxn, which is equal to n by theta power n integral over k to theta x n power n minus 1 dxn, which is equal to n by theta power n. Then what is the integral value for this? Is equal to xn power n minus 1 plus 1 divided by n minus 1 plus 1, right? Range k to theta, which is equal to n divided by theta power n x n power n divided by n k to theta, which is equal to here n got cancelled. Then 1 by theta power n. Then substitute value for xn. Here xn theta is replaced. Xn is replaced by theta, right? Theta power n minus k power the lower limit k power n, which is equal to theta power n minus k power n divided by theta power n. Understood? Which is equal to, we can write this term as 1 minus k power n divided by theta power n. This is beta of theta. This is beta of theta. So we have to find out whether beta of theta is increasing function or decreasing function, right? So for that we have to differentiate beta of theta, right? Then what is b dash of theta? That is differentiation of beta of theta. So we know that what is beta of theta? Beta of theta equal to 1 minus k power n divided by theta power n, right? So differentiation of b dash of theta equal to, first term is 0, then dou by dou theta power k power n divided by theta power n, right? Which is equal to 0 minus the differentiation of k power n divided by theta power n is equal to k power n into minus n theta power minus n minus 1, right? Which is equal to minus minus got cancelled. Minus into minus is plus, right? So we can write minus k power n into minus n theta. We can write it as minus n plus 1. Same, right? Minus n minus 1 equal to minus of n plus 1. Same, right? Minus n plus 1 equal to minus n minus 1. Same. So we can write these as this type, which is equal to here minus into minus plus, right? Then k power n into n, and we can take this term here, that is theta power n plus 1, right? Is equal to n into k power n theta n plus 1, theta n plus 1, whether it is greater than 0 or less than 0. It is greater than 0, right? Because all values are positive, so it is greater than 0. Therefore b dash of theta, therefore beta of theta is a increasing function or decreasing function? Is a non-decreasing function of theta, right? Here b dash of theta is greater than 0, therefore beta of theta is non-decreasing function of theta. Then under h naught, beta of theta attains maximum at which value? And h naught, beta of theta attains maximum at which value? Here in the question, theta is less than or equal to 10, right? Here we know that beta of theta is a non-increasing function, right? It's given that here in the null hypothesis given that theta is less than or equal to 10, right? So in the uniform distribution, here x follows uniform 0 comma theta, right? Then the range of theta is greater than theta. So here we can take theta to 0 to 10. Here is given that theta is less than or equal to 10. So here this is theta value is a beta of theta is a non-decreasing function, right? Beta of theta is a non-decreasing function, which means is an increasing function. So here when beta of theta is maximum, the value of theta equal to 10, then beta of theta tends maximum, right? So you can write under h naught, beta of theta tends maximum at theta equal to 10, right? Understood. Next we have to find out the size of the test, right? Size of the test is equal to supremum of expectation of phi of xn under null hypothesis, right? So here size equal to expectation of phi of xn, theta equal to which value? Theta equal to 10, then beta of theta tends maximum, right? So here theta equal to 10, which is equal to, what is the value of expectation of phi of xn? Expectation of phi of xn is equal to, you know that beta of theta equal to expectation of phi of xn, right? So in here we obtain what is the value of beta of theta. Beta of theta equal to 1 minus k power n divided by theta power n, right? So here 1 minus k power n divided by theta power n, right? Here size is become null hypothesis, that is we can take theta naught, which is equal to 1 minus k power n divided by, what is the theta naught value here? Theta naught is 10, right? So 10 to the power n. In the problem is given that what is the sample size, right? What is sample size? N equal to 10 is given, right? So we can substitute that value, that is k power 10 divided by 10 to the power 10 equal to 1 minus, and here also k is given, right? In the question k is given. Compute the size of the test when k equal to 9, right? So substitute value of k, that is k is 9. It's equal to 1 minus 9 to the power 10 divided by 10 to the power 10, which is equal to, what is the value of that? 1 minus 9 to the power 10 divided by 10 to the power 10 is equal to 0.6531. This is the size of this test, 0.6513. Okay, understood. Then there is one more question is, right? We have to obtain the power function of the test when theta equal to 8.5, 9, 10, 15, 20 and 25. So what is the formula for power function of the test? We know that power function of the test is probability of rejecting H naught under parametric space, right? What is power function of the test? Power function of the test is probability of rejecting H naught for various values of theta under parametric space, and it is defined as beta of theta. It is defined as power function of the test equal to expectation of phi of xn under for various value under parametric space, right? Here expectation of phi of xn is beta of theta, right? We know that what is the value for beta of theta? Beta of theta. Power function of the test is also denoted as beta of theta, right? So here the value is 1 minus k power n divided by theta power n, right? And here we know the value for k and n also, that is 1 minus k is 9 power 10 divided by theta power 10. This is the power function of the test. But in the question is asked, obtain the power function of the test when theta equals 8.5, 9, 10, 15, 20 and 25, right? So we have to find out power function, the value of power function of the test when theta equal to 8.5, theta equal to 9, theta equal to 10, theta equal to 15, theta equal to 20, theta equal to 25, right? That is beta of theta equal to 1 minus 9 to power 10 divided by 8.5 power 10, which is equal to, what's the value for that? 1 minus 9 divided by 10 whole power 10, right? Sorry, 1 minus 9 divided by 8.5, right? 8.5 power 10. Then the value is minus 0.7710. Is it possible or not? It's not possible, right? Because beta of theta means the probability of rejecting H naught under parametric space, right? Whether the probability value becomes negative or not. Probability value lies between 0 and 1, right? So this is not correct answer. Here this value is not valid. Okay, then we check for theta equal to 9. Then power function of the test equal to 1 minus 9 divided by 9 power 10, which is equal to 9 is 1, right? 1 minus 1 is 0. Okay, next beta of theta equal to 1 minus 9 divided by 10 power 10, which is equal to 0.6513, right? Then theta equals 15. Then power function of the test equal to 1 minus 9 divided by 15 power 10 is equal to 1 minus 9 divided by 15 power 10 is equal to 0.9939. Then for theta equal to 20, beta of theta equal to 1 minus 9 divided by 20 power 10 is equal to 0.9996. So similarly, you can find out value of beta of theta when theta equal to 25. This is the power function for the test for various value of theta. Understood? Is it clear? Then we will go for another problem, and the question is given a random sample of size n from a distribution with the density f of x theta equal to 2x divided by theta square, where 0 less than x less than 0, x less than theta, where theta is greater than 0. Okay, then for testing h naught, theta is greater than equal to theta naught, versus h1, theta less than theta naught. And here the test function is given by phi of xn equal to 1 if xn less than k, 0 otherwise. And the question is determine this k value, determine k such that alpha equal to 0.1. Alpha means the size of the test here, and theta naught equal to 5, n equal to 10, and here also obtain power function of the test for theta equal to 4.5, theta equal 4.5, 5, 5.5, 6, 6.5. So here the question is given a random sample of size n from distribution with the density f of x theta equal to 2x divided by theta square, 0 less than x less than theta, theta greater than 0. For testing h naught, theta is greater than or equal to theta naught, versus h1, theta is less than theta naught. For testing, the test function is given by phi of xn, 1 if xn is less than 1, 0 otherwise. So here we have to determine the value for k. So it's given such that alpha equal to 0.1, theta naught is 5, and also it's given that n equal to 10. And this problem also we have to find out the power function of the test for theta equal to theta equal 4.5, 5, 5.5 and 6, 6.5. So here we have to find out, first we have to find out the size of the test, right? Size of the test. And here the solution is we know that what is size psi is equal to supremum expectation of phi of x, theta is belongs to theta naught, right? But in here, in this problem, psi is equal to supremum expectation of phi of xn under theta is less than or equal to theta naught, right? In this problem is given that. Then we have to find out the size of the test. For that, first we have to find out beta of theta, right? So here what is beta of theta? Beta of theta equal to expectation of phi of xn, right? It's equal to 1 into probability of xn is less than k plus 0, right? It's equal to probability of xn less than k under theta, right? So here also we have to find out the density of nth order statistic, right? Density of nth order statistic is, we know that the formula for find outing the density of nth order statistic, right? That is f of xn equal to n into capital f of x, where x equal to xn power n minus 1 into f of x, where x equal to xn, right? So we have to find out what is f of x, right? So here in this problem is given that f of x equal to 2x divided by theta square, right? So we have to find out what is f of x, that is 0 to x f of x dx is equal to 0 to x 2x divided by theta square dx is equal to, we can take 2 divided by theta outside, then 0 to x dx which is equal to theta divided by 2 divided by theta, then integral over x dx equal to x square divided by 2, right? Which is equal to x square by theta, right? Then here substitute the values. So, f of xn equal to n into f of x, where x equal to xn, right? So here we got what is f of x, that is x square divided by theta. So here n into xn or xn square divided by theta, right? Here capital f of x equal to x square divided by theta, but in nth order statistic formula we have to write f of x where x equal to xn. Then here f of x of n square divided by theta power n minus 1 into f of x, where x equal to xn, right? Here f of x is 2x divided by theta square. Then you can write here 2xn divided by theta square, right? So we can write this term as n into xn divided by theta power power 2 n minus 1 to xn divided by theta square. You can write it as n into xn power 2n minus 2 divided by theta power n minus 1 into 2xn divided by theta square, right? It's equal to n into xn power, here xn power 2n minus 2 and also here 1xn, right? So equal to 2n minus 1, right? Divided by theta power n minus 1 here and also here theta power square, right? theta square, right? So we can write it as, oh, here theta square, right? Theta square, and also here theta square. So here theta square, then here theta square minus theta 2n minus 2, right? And also here theta 2n minus 2 plus theta square, then we can write it as theta 2n. Okay, then here we got f of xn, nth order density, right? Then what is beta of theta? Beta of theta equal to, here beta of theta equal to probability of xn less than k, right? Probability of xn less than k under theta is greater than equal to theta naught, right? So we can write it as integral over 0 to integral over 0 to k, integral over 0 to k 2n power, what is this value? The density is n into xn power 2n minus 1 divided by theta power 2n, right? So here we can write xn 2n minus 1 divided by theta power 2n dxn, right? Similar like last problem. Then take 2, here 2 is there, right? So 2n divided by theta power 2n outside, then integral over 0 to k xn power 2n minus 1 divided by, okay, there is not any, so you can write it as 2n divided by theta power 2n integral over 0 to k xn power 2n minus 1, right, into dxn. So it is equal to 2n divided by theta power 2n, here xn, this value is xn power 2n divided by 2n, range is 0 to k, right? It's equal to, here 2n got cancelled, then you can write 1 by theta power 2n, here substitute xn as k power 2n minus 0, right? So which is equal to k divided by theta power 2n, right? So it is beta of theta. Beta of theta equal to k divided by theta power 2n. So we have to find out whether beta of theta is increasing function or decreasing function of theta, right? For that we have to differentiate beta of theta, that is b dash of theta equal to, what is the differentiation of this term? What is the differentiation of this term? K power 2n minus 2n into theta power minus 2n plus 1, right? So we can write it as k power 2n divided by k power 2n into minus 2n, right? Minus 2n divided by theta power 2n plus 1. whether it is greater than 0 or less than 0. It's less than 0, right? So we can say that beta of theta is non-increasing. Beta of theta is non-increasing function of theta, right? Beta of theta is non-increasing function of theta. Then we have to find out for the which value of theta beta of theta attains maximum, beta of theta attains supremum, right? So under H naught, beta of theta attains supremum at which value? Here beta of theta is non-increasing function, that means is a decreasing function, right? Is a decreasing function. And what is null hypothesis here? What is null hypothesis here? Null hypothesis is theta is theta is greater than equal to theta naught, right? So here in this here is value is theta naught to something values. This is the theta value. Then we know that beta of theta is non-increasing function, which means the decreasing function. Then beta of theta attains maximum when theta equal to theta naught, right? Here theta equal to theta naught. Under H naught, beta of theta attains supremum at theta equal to theta naught. Then what is size of the test? Then size of the test equal to expectation of phi of xn under theta belongs to theta naught. That means theta equal to theta naught, right? Which is equal to what is expectation of phi of xn? That means what is beta of theta? Beta of theta equal to k divided by theta power 2n, right? K divided by theta power 2n. Here theta equal to theta naught, right? So we can write as theta naught here, right? So here we have to find out in the question what is that. So we need to find out the question. We need to find out determine k such that alpha is 0.5 and theta naught equal to 5 and n equal to 10, right? So we have to determine k. Here size of the function is size of the test is given, right? The size of the test alpha equal to 0.1. Here 0.1. That is size of the test alpha equal to k divided by theta naught power 2n, right? Then how to find out determine k value? So which implies we can take this term here, then it becomes theta naught power 2n alpha equal to k power 2n, right? Then we want to determine the what is the value for k, right? Which implies that k equal to alpha power 1 by 2n into theta naught. Understood? So which implies what is the value for k? K equal to alpha. We know that alpha is given, right? Here alpha is 0.1 is given in the question, right? So 0.1 power 1 by 2 into what is the n here? N is also given, right? N equal to 10. So 2 into 10. Then what is theta naught here? Theta naught is also given. Theta naught equal to 5 into 5, right? Is equal to, then what is the value for k? Then what is the value for k? Is equal to 4.45625. This is the value for k when alpha equal to 0.1, n equal to 10, and theta not equal to k. For this test, k equal to 4.45625. Understood? Then here we have to find power function, which is equal to expectation of theta, expectation of phi of x n under theta, right? Which means beta of theta equal to k divided by theta power 2a. It's equal to, here we find the k value, right? That is 4.45625 divided by theta power 2 into n. N is 10, right? Then 2 into 10, 20. So here we have to find the power function of the test for various value of thetas, right? So in that, given that theta equal to 4.5, then what is value of power function? It's equal to 4.45625 divided by 4.5 power 20. It's equal to, what is the value for that? 4.45625 divided by 4.5 power 20. It's equal to 0.8225. This is the value of the power function when theta equal to 4.5. And also we have to find out theta equal to 5. Then beta of theta equal to 4.45625 divided by 5 whole power 20, which is equal to 0.09997. Is the value, is the power function of the test when theta equal to 5. Understood? Then you have to find out what is the value of beta of theta when theta equal to 5.5, theta equal to 6, theta equal to 7. This is your homework. Understood?